Okay, so we were discussing this question of years, and today is Makar Sankranti, so we are going to proceed further from the topic of years. And there's a next question related to cards this time. Two cards are drawn from a pack of 52 cards. Okay, the probability that both we have to find the probability getting both red cards or both king cards. This is what we have to find out. Okay, so let's solve. Two cards are drawn from a pack of 52 cards. We have to find out the probability of both cards being red or both cards being king cards. Okay, so let's consider the first event of getting both cards as red as event 1. Let's wait for see event 1, and this is event 2. Or so we need to find out probability of event occurring unison or like union sets of both of the events. Formula we are aware. And excluding the case when both of the events are happening simultaneously. Okay, so both cards will be red when how many? So basically, if we are withdrawing two cards from pack of 52 cards, so total weight of selecting two cards from pack of 52 cards is this. Yes. So now, how many red cards are there in a pack of 52 cards? It is for sure that we have to select two cards. Both of them has to be red. How many total red cards are there? 52, 26 red, 26 black. So we have to select two red cards from 26 red cards. We are selecting two cards at random from 52. Event 2 is getting king cards. How many kings are there in 52 cards? It is for we have to withdraw two cards, four kings out of like we have to withdraw two king cards. How many total kings? Four kings. So in 4C2 ways, number of ways, we'll be able to find out. We will be able to withdraw two cards that are kings minus when both the cards are king and red. How many red kings are there? Two, right? So we'll select two cards out of two. And of course, we were withdrawing two cards in like total number of cases. Total number of ways is this only. So let's now solve for it. 26C2. The LCM is basically 52 C2. 26 C2 is 26 factorial divided by 24 factorial into 2 factorial plus 4C2 4 factorial upon 4 minus 2 factorial into 2 factorial minus 2C2 is basically 1 only. 2 factorial upon 2 minus 2 0 factorial 2 factorial, that is 1 only. Okay, so this has become 1. 2 cancels. 4 factorial is 24. 24 by 2 is 12. 12 by 2 is 6. This has become 6. 24 cancels 26 with 26 into 25. 2 cancels 26 with 30. This has become 13 into 25. Okay, that is so. So let's now calculate. 13 into 25 will be 13 5 is 65. 6 carries. 13 2 are 26. 26 and 6, 3 2 5. Plus 6 minus 1 divided by 52 C2. 6 minus 1 becomes 5. 5 plus 325 becomes 330 divided by 52 C2. 52 factorial, 52 minus 2, 50 factorial into 2 factorial. 50 factorial cancels 52 factorial by 52 into 51. 2 cancels 52 by 26. Now this is 26 is having factors as 2, 13, and 51 is having factors 3 into 17. So yes, we know that this is divisible by 3, 1, 1, 0, and 51 by 3 is 17. Yes, both are even numbers. So 26 by 2 is 30, 110 by 2 is 55. And now I cannot see any other multiples. This is become 55 upon 13 into 17. 17 into 13, 13 7 is 91, 9 carries, 13 1 is 13, 13 plus 9, 22. So now the answer is this. Let me check. Yes, it is the right answer. 55 by 220. Is there any doubt, anyone? Okay, if there is no doubt, shall we move ahead? Shall we?
Yes, sir.
The next question is, a bag contains six bowls. Sorry, 6 white bowls and 4 black bowls. A man pulls out 2 bowls at random. A man pulls out 2 bowls at random. The probability of getting both bowls of same color is what we have to find out. Okay. So there is a bag. Let's throw it. There's a bag. Okay. There is a bag. Okay. Now I have plugged in the charger. Maybe it will not do mischief now. So this is a bag having 6 white balls, 4 black balls, 2 balls are pulled out. So total number of ways to get 2 balls out of total 10 balls is 10 C2. The favorable event is getting both balls as of same color. So one event can be when we will get 2 white balls. So we will select 2 balls out of 6 white balls, or we can get both of them 2 balls of black color. So 2 balls of black color. These are the 2 events that are possible. There are no other colors. Yes, they are um they are independent events, because that particular event of getting two black ball is a complete event, and getting two white balls is a complete event in itself, because the event wanted only two balls to be drawn. So that's why this is a complete event when we are pulling two balls out. Is that clear, everyone?
Yeah.
6 factorial gets cancelled by 4. 6 into 5. 2 cancels 6 by 3. 8 factorial cancels 10 factorial by 10 into 9. 3 cancels 9 by 3. 2 factorial cancels 10 by 5. 5 cancels 5. This has become, sorry. This has not become this. This is the first step only. Is there anything else left? Anything left? No. Discussion of 4C2 is 6. I remember it. Otherwise, I hide it also. 10 factorial is 10. 10, 8 factorial, and 2 factorial. So this has become 8. That has cancelled. 10 into 9. 4 or factorial is cancelled by 2. 4 into 3. 2 cancels 4 by 2. 2 cancels 10 by 5. 3 cancels 9. 3 cancels 9 by 3. Nothing else left. This is basically 1 by 3 plus 2 by 15. Taking 15 LCM, 5 plus 2, 7 by 15 is the answer. Correct answer. Is this clear? Once you have understood that how the question will be solved, the remaining part is the calculations one. Now there is a very important question coming up. This time 3 dices are thrown. Okay. This time 3 dices are thrown. The probability of getting a total of at least 6, is that what we have to find out? I guess we have discussed this question where we have calculated that at least 6, 7, 8, and then till 18. So if we will count all the cases, that will be a lot for us to discuss. Instead of that, we can just go around the table and we'll find out the probability. We'll calculate it by 1 minus probability of its reverse, getting a total of at most 6. At most 6, where 6, the case of 6 will be not included, because here 6 is included. Here we will exclude the 6. So getting a sum of 3, 4, 5. How it can happen? We'll consider these scenarios only. And we have already discussed it. Still, let's do it once again. How 3 can be made by 1 plus 1 plus 1. How 4 can be made 1 plus 1 plus 2. Or this have 3 arrangements. Okay, because 3 factorial upon 2 factorial, 2 factorial because of the repetition of 1. And 4 can be made by 1 plus 3, 1 plus 2 plus 2. No, this is the only case, I guess. There are no other numbers which can make 4. Yes, there are no other. 1 plus 2 plus 2. These have also 3 repetitions. And 3 plus 2 plus 0 cannot happen because 0 cannot be a result on any dice. And 2 plus 2, we have already considered this. 1 plus, this is the only scenarios. So how many? 3 plus 1, 7 favorable outcomes out of out of how many cases total? There were 3 dices. All can have 6 results. So 6 raised to power 3. 7 by 6 raised to power 3 is the probability of this answer. So we'll 1 minus 7 by 6 raised to power 3 is 216. 216 minus 7 divided by 216. That becomes are we missing on something? 1 plus 3 plus 3. Is there any other way to make 5? Because this question is becoming absurd. And we have to be careful in this type of calculations. 1 plus 2 plus 2, 3 plus 2, no, cannot. 3 plus 1 plus 1, 3 plus 1 plus 1, 4 plus 1 plus 0, no. And 3 plus 1 plus 1, okay. 3 plus 2 cannot happen. 3 plus 2 plus 0, 0 cannot be any outcome of any device, any dice. Or 2 plus 1 plus 2, okay. 2 plus 3 plus 1, no, no, no. 1 plus 1 plus 3. We have already counted this. This have also 3 arrangements. So 3, 3, 6, 3, 3, 6, 3, 9, 9 and 1. That's 10. 10 divided by 6 minus. This will be our answer. We have solved this question earlier also. Is there any doubt? There is
Yes,
any repeat? No. Okay, so this time we will not withdraw 3. We will withdraw 4 cards. Thrown at random from a pack of 52 cards. We know that. We have to find out the probability of getting all 4 cards of same number. How many same number of cards are there in a pack of cards total? Let me ask you this in this manner. How many cards are there having 10 number on it? Just think. Um, 10 of heart, 10 of
what
diamond.
40?
Yes. 10 of, it's hard to do. 10 of spade. How that's made? There are 4 cards of same number. Okay. So either we can get like 4, 10. There is a single case now in which these particular event should happen for being a 10. Okay. So for a single number, there are specific 4 cards available. Okay. There are 4 cards. Has to be this. If we are withdrawing 4 cards, so they has to be from different shoots. Okay. And like let's list all the favorable events. Withdrawing 1 from the heart, it doesn't matter कहाँ से भी है, it do not matter, but it has to be all 1 or 2 2 2 2 or how many times, how many same cards are there, same cards. So see, the question changes when it is written same number or same cards. If like number is there, then still we can consider there are 13 cases possible, but not exactly 13 will be there. You know what will be there? क्या होता है 13th? There's a ace, there's a number card 2 to 10, and there's a jack, queen, and king. Yes, king. Not exactly, but they are the same number cards. So how many cases, how many favorable events are there? 1, 2. Similarly, 13 favorable events are there. 13 favorable events are there. Now, if there is any difficulty in understanding this, please do ask. Is there any difficulty? Or is that clear? If there is any, let me repeat.
Yes, sir.
There are 52 cards, 4 different shoots. Okay. All are having number card, let's say 1 to 13 cards of similar nature with 4 shoots. So if one card is withdrawn with one number of heart, let's say, then other cards has to be one only. Okay, so that's one case for one number. For second case, if two cards, if a card with number 2 is withdrawn from heart, then other cards has to be 2 only. So similarly, we will this is the first event, this is the second event, this is the third event. So similarly, there will be, these are our favorable events. Similarly, there will be 13 such favorable events. Let's try to list them all. Like 3, 3, 3, or 4, 4, 4. What's happened? Let me save the file. Until then, let me explain. Key, in every event that is favorable to us, there is only one way for it to happen. Now, it cannot be like that. Key 1, 1 and 2, 2 and 1, 1 and 3, 3. No, all the cards has to be same. So there is only single way of selecting the cards, right? So there are 13 such favorable events. Similarly, 13th card, which is the king. Now this is also 13th event. 13 favorable total events are there. So how many total favorable events are there? 13. And when we are selecting 4 cards out of 52, so there are 52 C4 number of cases in which we can select them. These are the total number of ways to select 4 cards. Favorable event being, this is the first event, this is the second event, third event, fourth event, and 13th favorable event. Favorable because they are all of same number. So 13 divided by 52 C4, 52 factorial divided by 52 minus 4, that is 48 factorial, and into 4 factorial. Now let me tell you a trick other than writing this again and again. If you are discussing about 52 C4, then simply write 52, 51, 50, 49. Keep on writing till the number 4, or if 4 is, if like NCR is there, right? Then write n into n minus 1, n minus 2, till the time you have written it till r number when r is equal. Or sometimes it may happen. Sometimes it may happen that 52C, 48 is that we are counting. Then still, take the take the smaller number out of these two. Take the R or N minus R. Okay, if R is bigger, then consider N minus R is what here? That's 4. So write 52, 4 times only, 51, 50, and 49. These are the 4 times divided by what is left now. N minus R is used, R factorial. Oh, sorry. Divided by R factorial. Simple, as simple as that. Divided by, sorry, I'm missing. Divided by the smaller number that is there out of these two, 4 factorial. Now let me prove how it is equal. 52 factorial divided by 52 minus 48 factorial, that is 4 factorial, 48 factorial. Now 48 will cancel this by 52 into 51 into 50 into 49. And that is what is written here also. So simply consider one of the two number and simply write these by subtracting one consecutively. Considering this, you'll be able to understand with practice. You'll be familiar with this. But by just looking on it, it will be looking absurd and very witty in a way to take a shortcut. But you have to be fast. Coming back, was that thing clear? How we have written 52C4 as directly 52 into 51 into 50? Is that clear? Because later on it's just going to get multiplied, na? It's just going to get cancelled. 52 can be expanded like this: 52 into 51 into 50 into 49 into 48 factorial. 48 factorial is there in the denominator, so it's going to cancel it. So that's why we have just ignored writing this. If you are confused, then you can also use a conventional method as we have done here. 48 will cancel 52 by 52 into 51 into 50 into 49. Now 4 factorial is 24. Write 24 here. And 24 by 2 is 12F. 52 by 2 is 26. 12 by 2 is 6. 26 by 2 is 13. 6 by 2 is 3. 50 by 2 is 25. And what else? 3. 51 by 3 is 17. 13 is a prime number. Yes, 13 cancels 13, which is left. 26 was already cancelled. Now there's nothing in the numerator. So 1 by 17 into 25 should be our answer. If we are solving it rightly. 1 by 17 into 25 should be our answer. And which is 25 into 17. 7 5 is 35. 3 carries. 7 2 is 14. 14 and 5, 19 plus 3. 19 plus 3, 22. 2 carries. 1 2 is 2. 4, 25. This should be the answer. Is that clear, everyone, now? And it is not given like this in options, or in options there are options with direct C4 value. So the option with 13 by 52 C4 is the correct answer in the book. Is this question clear, or should I explain it once again? If you want it, I'll do it.
Yes, sir.
Clear?
Yes, sir.
Okay, so now we are going to talk about the defectiveness in electric bulbs. So we have a box. There's a box having 20 bulbs, electric bulbs, out of which 4 are defective. In this 20, 16 are good and 4 are defective. I'm writing cross to denote defectiveness. 2 bulbs are chosen at random. The probability that at least one of these is effective. Okay. So if 2 bulbs are chosen, then what can happen is that we have taken the first bowl, uh, we have to first, let's understand the question well. We have to find the probability of at least one bulb to be defective. Okay, this is the question. Is the question clear, everyone?
Yes, sir.
So let's discuss the solution. So how many total ways are there to select 2 bulbs? Let me save the file. Total number of ways to select 2 bulbs out of 20. Can anyone tell me how many total number of ways are there to select 2 bulbs out of 20 bulbs? Simple question. Isn't it NCR to select R things out of N? So 2 out of 20. There's a total number of ways to select 2 bulbs. Okay. Whenever this kind of question means that if you are selecting one defective or 2 defective, okay, because there can be only 2 defective. There cannot be any bulbs more than 2 defective because we are selecting only 2 bulbs only. So at least one means number of cases considering here the probability of this plus the probability of being the uh, both of the bulb as defective. So instead of finding the both of the cases, we can go around, find something else. So probability of this event, let's call this event as E, can be written as 1 minus of P of bar. So probability of getting no bulbs defective. This is basically, let me draw a table now. Let me draw a table now. And that is very important concept for you all to understand. Total equals to exactly 0. If 0 exists, exactly 1, exactly 2. This is not in the context to the question, but it's a topic itself. Or it goes on and on and on. Now we are going to discuss about at least one. If we are discussing about at least one, so it means that we are including, it means that we are including one, we are including one, array draw. It means that we are including one for sure and more than one cases also because at least one is there. That is the case here. When we are discussing at least two means more than two and also two. And also two is also in consideration. So these are the cases of at least one, at least two. But when we say at most one means oh, at most one also includes one, but it goes on decreasing. We come from the left hand side, starting from the left hand side, or we can start from the one itself. At most one includes one for sure, and but it gets decreased with time. The degree gets at most one and less than one. So that is the difference here. To find at least one defective, we can find the total cases, the probability of total, which is actually one, minus getting exactly zero defective bulbs. So at least one defective can be written as the probability of sure event, because that's the universal set. So the probability of universal set, or the probability of uh, or the event of taking two bulbs is one. So that's the totality is here, taking two bulbs, and that is for sure. We are doing it already in the question. So probability of at least one effective bulb will be equal to 1 minus probability of getting no bulbs defective. Is this point clear? Should I repeat? See, be very sure if you are not sure now. Be very sure to tell that we do not know, and sir, we are not able to understand, or sir, you are not able to make us understand. It's completely fine. You can tell me that, only we can discuss it wisely now. Should I repeat?
Yes, sir.
Yes, sir. So there is a bag having total 20 bulbs, 16 okay bulbs and 4 defective bulbs. We are getting 2 bulbs out. Okay, that's the event happening. And we have to tell the probability of getting at least one bulb defective. When we are withdrawing 2 bulbs out of 2 bulbs at random. That is the question. Now it's a point to understand. So at least one bulb be defective. So at least one bulb means one bulb is defective. The event includes, let's say this is the event. So this event includes one bulb being defective plus 2 bulbs being defective. That's the favorable event. What all events are there when we withdraw 2 bulbs? So both of the bulbs can be right, right? Both of the bulbs can be okay, non-defective, or one of the bulb is non-defective, or both of the bulbs are non-defective. These events can happen, right? Now we have to talk about the possibility of these events. And we know possibility of all of these events is definitely 1. So now that we know that the possibility of getting at least one bulb defective means one bulb or 2 bulbs defectiveness, and this is no bulb defective case. So if we find out the probability of this event. Okay. And we know the probability all events, like some of the events has to happen. So its probability is 1. And we have to find out the probability of the collectiveness of both of these events. Let's call it the event 1. Now, instead of finding out the probability of event 1, what is, and we need to find out, this is the question. This is the need of the hour. So we can write the probability of event 1 of getting at least one bulb defective is 1 minus probability of getting no bulbs defective. Is that clear now? How we have written it like this, 1 minus getting no bulbs defective. There are total 20 bulbs. There are 16 correct bulbs working, tested okay bulbs, 4 defective bulbs were there. We have to withdraw 2 bulbs. Okay. So we have to withdraw 2 bulbs. So how many cases are there? There are 2 cases in an event. So every bulb can be defective or not. So 2 choices. This bulb can also be defective or not. Another 2 choices. So total number of 4 cases can be there. So let me write defective by D and okay with O. Okay. So both of the bulbs can be defective. One bulb can be defective, or both of the bulbs can be okay. Right. These are 3 events that can happen without 2 bulbs. We are only discussing about the selection. Arrangement doesn't matter here. Okay. So that's why we have not written OD here. Hana? So both of the bulbs can be defective. One can be defective, or both of them can be okay bulbs. So now we have to tell about at least one defective or more than one defective. These are the 2 cases that we are talking about. Now, instead of finding the probability of this event and then adding it to the another one, we are just doing that we'll find out the probability of this only remaining event, and we'll subtract it from the 1 so that the probability of remaining is come. Because what happens is that we have discussed about this concept earlier, that probability of any event is equals to the probability of 1 minus probability of that event not happening. So here the probability of getting at least one bulb defective. What was the aim? What was the event's aim? Was to get some bulb defective when we are withdrawing 2 bulbs. So it will not be happening when we will discuss about the probability of getting no bulbs defective. Is that clear now? Probability of any event is equals to 1 minus probability of event not happening. It's like it is same like when there are 100%, there are like you can get 100% marks, but in reality you have got in your test 50%, 55% of marks you have scored. So how many marks didn't you score? Was 100% minus 55%. So 45% of marks you didn't score. And in case of marks, there was 100%. In case of probability is 1. So for any event happening, probability of event is this. So this is the event happening probability. Event not happening probability is 1 minus P of E. What was our event? Getting a bulb defective, 1 bulb, 2 bulb, 3 bulb, doesn't matter. But getting at least 1 bulb defective. So the event will not happen when there will not be any bulb defective, right? Is that clear now?
Yes, sir.
Okay, great. So there will not be any defective bulbs when we will select. Now let's solve on next slide only. Sixteen okay bulbs, 4 not okay bulbs, 1 minus probability of getting all okay bulbs. No defective bulbs. If there are no defective bulbs, then what is our desirable choice? 16. Yes, we have to select our 2 bulbs out of 16. Okay, selected. And total number of cases are there to select 2 bulbs out of all bulbs. That's the total number of cases. Now let's solve for it. 16 factorial divided by 14 factorial into 2 factorial. 20C2 means 20 factorial divided by 18 factorial into 2 factorial. 14 factorial cancels 16 factorial by 16 into 15. And 18 factorial cancels 20 factorial by 20 into 19. Okay, 2 factorials cancels 2 factorials. And 4 4s are 16, 4 5s are 20, 5 3s are 15, and 19 is a prime number. So 1 minus 12 by 19, that will become 7 by 19. Is the question clear, everyone?
Yes, sir.
Yes. So basically, probability is all about understanding the question well, and then to avoid major calculations and strenuous work, we'll have to consider smart ways to go, like the straight way or the bend way. Like shortcut are preferable, and you have to be lazy before solving the question. First, read the question, understand the question, then think for the best and shortest method that you can use to solve the question. Now, there is no space for drudgery here. Don't waste time. Just be lazy. Think for the short method. And there are short methods for most of the questions. Some questions don't have any short methods. So for those questions, you just have to drop those questions and come back later when you have lots of time, if you have any. That is the strategy. Shall we conclude the class now?